Here's 5.1, day 1, part 2. This is the first set of identities that I do want you to now write in your notes. What we've covered so far on page 354 is those quotient identities and the reciprocal identities from chapter 4. These three identities are not in your notes. They're from chapter 5. It's called the Pythagorean identities. Sine squared of u plus cosine squared of u equals 1. That's the most popular of the three identities. Then 1 plus tangent squared of u equals secant squared of u. And then 1 plus cotangent squared of u equals cosecant squared of u. You can use these identities to replace within some functions. Now, if I rewrite this equation as such, I could solve them for the different trig function. So if I want to take this first Pythagorean identity, sine squared of u plus cosine squared of u equaling 1, and set it equal to cosine squared of u, then it would be 1 minus the sine squared of u. We're just rewriting the order of the terms. So we would subtract sine squared of u. Or you can use this same identity and solve it for the sine squared of u. So sine squared of u equals 1 minus cosine squared of u. So you can rewrite the order of these terms to replace. Same thing with the last two equations too. You can also solve these separately. On page 354, the co-function identities. Write these down. They're not in your notes. And I purposely left the right side blank. I want you to see if you can find those on page 354. The sine of pi over 2 minus u equals what? What does it equal on page 354? Did you find it? Equals cosine of u. Remember when we were graphing the trig functions for sine and cosine? We noticed there's a strong similarity between the two functions. It's just a transformation left or right, pi over 2. And then the cosine of pi over 2 minus u is sine of u. All right, and then the last set of identities are called the even and the odd functions. Left the right side blank for you. Sine of negative u equals negative sine of u. Now that u can represent x or theta. Cosine of negative u equals the cosine of u. And then the tangent of negative u equals negative tangent of u. Okay, now we'll go on to doing some practice using some of these identities. So the hint is rewrite this expression so that it's all sines and cosines. So what this expression is saying is sine raised to the 4th power of x. So there's 4 sines of x's. It's the sine of x times the sine of x times the sine of x times the sine of x is what that sine of fourth power is. Times the cotangent raised to the fourth power of x. So there's 4 cotangents. How can I rewrite one or both of those expressions so that's all in sines and cosines? What might I want to do? What's the cotangent of x? That's one of the ways I can rewrite the cotangent of x. I can rewrite it as 1 over tangent, or what else? Cosine over sine. Do you agree? Which one would be the better choice? Cosine over sine? So we're rewriting that cotangent to the fourth power of x as cosine to the fourth power of x over sine to the fourth power of x. What would be the next step after that? How did that help us out? Correct, the sines cancel out. So what's our answer then? Cosine to the fourth power of x. All right, another hint is factoring might help you to simplify an expression. What can we do to factor here? What would be one of the things I could factor out? Sine squared of x plus sine squared of x times cotangent squared of x. What's the first thing we do when we factor? We look for what? The greatest common factor. Is there a greatest common factor between these two pieces? What's in common with this piece of the expression and that one? Is there a GCF? Yep, I can take this piece out and this piece out, correct? So what am I left with in the first term then? In the first one, if I took out that sine squared of x, I'm left with 1. If I take the sine squared of x out of this one, I'm left with. So the sine squared of x is your GCF. So we're left with 1 plus cotangent squared of x. Now let's see if we can replace, again, with something else. See if you can find in your notes any identities that might help you to replace. Look at your Pythagorean identities. One plus cotangent squared of x equals what? One plus cotangent squared of x equals, what is it? Cosecant squared of x. So can I replace this parentheses with cosecant squared of x? Yes. Now we have it into 2 pieces. How can I rewrite cosecant squared of x? What's cosecant? 1 over the sine, correct. So cosecant of x equals 1 over the sine of x. Reciprocal identity. How did that benefit us now? What will be the next step? What cancels? Sine squares of x cancel. So our final answer then is 1. So that beginning expression reduces all the way down to 1. Okay, stop there.